I was like, hi, my name is Stormy Benzie, and I am doing a lesson for grade 5 for my STEM class. Today's date is May 2nd, 2022, and I am here with Caleb. So, Caleb, today, like I said, we're going to be doing an activity or lesson, whatever you want to call it, over ice and water, like different states of matter. So, we'll just start off by watching this video. One second, I'm going to pull it up on this computer. Alright, so we're going to watch this video. I guess there isn't much for sound anyway. It's two ice. It says identical ice cubes are placed on a black squares of aluminum and plastic foam. Why does one melt faster than the other? That's just what it says for the video. I don't know. Alright, so that was a video. Nothing crazy, just ice melting. So I'm supposed to ask, what can you... Okay. So after watching that video, what could we infer from the video? What was this happening? What did you notice was happening?
That the movement and it misdirected. Just the movement is starting to like shake it and vibrate it to where it has like it's more hot when the thing's moving.
Right. So the video, what it shows us is those are two hot plates. One is on and one is off. So this is a video you're just explaining how the hot plate melted the ice faster than the one that was just off. Supposed to see, and then you're supposed to say have you been taught the states of matter yet?
Yeah.
Yeah. So how would you think what would you say the states of matter are? If you can think and remember, or at least the three main ones that I can think of.
Gas, solid, or liquid.
Yep, liquid. Yep, good job. All right, so how would you think that this video relates to those states? Like, what's happening here?
The gas coming from the hot plate is affecting the solid to turn into a liquid.
Good job. So yeah, exactly. That's exactly what I was looking for. That the heat, like you said, from the hot plate is causing the solid form of water to turn into its liquid form. All right, so let's. Darn it! I don't understand why it keeps falling down. I've never had this issue. All right, so exactly what you said. Okay, so discuss the observations. So where do you think the energy came from? I can't read. Where do we think that the energy came from to melt the ice? And you kind of explained that. You talked about, it moving really fast and the heat and causing it to melt. So that's kind of what that's looking for there. Okay, so you talked about the speed. So what do you think happened when the speed of the molecules when the ice was melted? So as it was turning to water, what do you think was happening to them? Were they getting faster or were they slowing down?
They were slowing down.
Let's see. I think we're just talking about it. Seated. I was just looking. I was like, now there's another video for us to watch. I might not be the best at this. I am still learning how to be a teacher, so I am trying. So, I'm supposed to give this to you now. Here's your activity sheet. I have a pencil here too, but we don't need to worry about it right now. And if you want to, you can take this towel off when we get there. I just thought it made it look nicer. So, already gave that to you, so I guess, so we do that. So after talking about that, about how, I think, one second, I don't want to tell you wrong about, so yeah, so what I thought. Okay, so you were close because I asked you what you think happened. Did they speed up or slow down? They were actually speeding up because the energy in them that's making it melt, and
Yeah.
then so when when things get frozen or they change to that solid form, that's they become so slow that it makes the form solid. That's why, because eventually they like.
My teacher taught me different.
Yeah, I just right. All right, so now I'm supposed to give you time to answer the first two questions on this thing. So, like I said, it might be easier to write. It just isn't. It's just dirty from all the years. It's stained. And then, so question one, I can say here because it's supposed to. I was grabbing ice cubes so we can keep going. Because the next part, we are going to actually do a little bit of messing around with these ice cubes and water, and we're going to make some predictions and test it out and see what happens.
Do you want me to set this up here real quick?
Yeah, that's fine. I just wanted to put this somewhere so the ice cubes can sit on there without making a mess.
Do you have a pencil sharpener?
I do not. This pencil might be a little sharper, but that's
Yeah. Just that one's starting to get dull.
right. Yeah, it's okay. It happens. I was like, I did have a pencil sharpener, but I let my friend use it and didn't get it back. But all right, so now I've distributed. I give you 2 cups. It says plastic cups, but I feel like clear is okay. 2 clear cups. One with some water in it, and one that's empty. So let me actually see your packet really quick for a second. So what it says we're going to be doing is you will work to design a way to make ice melt faster. You need to show that your method really does make ice melt faster. Be sure to use a control. Check your teacher before conducting your experiment. So the control is our ice cube. We have 2 ice cubes that are exactly the same size. So those, we know that those are the control. We can, that's the part we can keep the same, or that we know for sure. I feel like these don't go together. That's why I was struggling. That's why it took so long to get you in here. Okay, so we're just, I guess we'll mess with this part here in a little bit. For now, I guess we'll just let you answer this question here and this here. Well, I don't, maybe maybe I'm just supposed to tell you, maybe, because it says, right? Okay, so it says, I gotta pause this really quick. I'm so sorry. This is all right. Hopefully we have no more interruptions. So what were we doing? We were gonna. So it says to work with groups, but there isn't a bunch of people here, so we're gonna do like a group of me and you. So what we would do as a group is figure out, how to a way to make ice melt faster. Do you have any ideas of a way ice might melt faster?
To maybe heat up the water and put the cube in it, and the other cup we could put the cube in, see which one melts faster.
Right. I think that's a good. So we have both of these. It's room temperature in here, and this water is also room temperature. It's not cold. It's not warm, but we can put the ice in one cup and put ice in another, and wait for like a minute and see which one melts faster. Because and are you before we even do that, do you want to make a prediction of which one you think will melt faster? Because it's like the temperature in here is room temperature, the water's room temperature. But do you think? How do you think the ice will melt?
I think that the one in the water is gonna melt because when last time when I had a cup of water that was room temperature and I had another cup, I put ice in both of them because I wanted to see what happened. Back when I was learning sweets and matter, I found out that this one, the ice cube was gone and the water level was higher.
Right.
And the other one, the ice cube was getting there.
Right. All right. So, like that, and that kind of what we just talked about is kind of like this, and we can talk through this more than you having to fill it out. I know I had you fill out those too. It just depends because it's not like I'm gonna grade you on this or anything. This is me practicing to be a teacher. I get graded on this, not you. So, all right. So yeah. So the ice placed in the water will melt faster than the ice in the air. Since the water and the air are both room temperature, it may not be obvious that why the ice melts in the air or in the water faster than the air. It says there are so many. Sorry, I knew I was going to hiccup. Sorry. There are so many molecules in the water that can contact the ice that the transfer of heat that can contact the ice that the transfer of heat to the ice is much more efficient and faster in the water than in air. That sentence almost kind of sounded funny when I read it out loud. But yeah, it just pretty much the basics of what it's saying is I guess there's heat in the air and there's heat in water, even though it's not because we're not in a freezing temperature. So like there's heat in our air and like again there's heat in the water. It said even though the temperature is pretty much the same, the water's room temperature, it's room temperature in here, that the water the water molecules move faster than the air molecules. That's what I think I was understanding from that, and so that is why the ice in the water melts faster. I was like learning. I was like, I've been through this and I'm still learning. Okay. So now I'm supposed to show you another video. And before it says it has a little thing I can read. It says melting ice. As the ice is heated, oh my gosh, I got like a spot in my throat. As the ice is heated, the motion of the molecules increase. Eventually, the motion overcomes the attraction between molecules and the ice melts and become a liquid. I wonder if there's any sound to this. It appears not. I guess as it heats up, this is it getting warmer, or ice melting. This is what's happening to its molecules. Probably even right now in that cup that the ice is in. That's probably what's happening to it. If the ice isn't gone already. All right. So that was, like I said, that just as an example of what it looks like when the molecules are going. So yeah, I'll start this over again and talk a little bit more. Just doesn't have any sound, so that way you can look over at it while I'm talking if you need to. It says the water molecules in ice vibrate, but they don't move past each other. But as we saw, and what we'll see again, as the temperature increases, they begin to vibrate even more. And eventually their movement becomes so their movement overcomes their attractions and they can no longer stay in their ordinarily crystal structure. So it gets to a point where they're moving so crazy that like they gotta kind of start doing that. They start getting to sticking with other ones and they start turning into other things. All right. So many pictures and everything to show you. I failed by not having them all pulled up ahead of time. All right, so this is just a picture. Ice and water. After melting, the water molecules are close together. The closer together they were as ice. As liquid, the molecules are more randomly arranged, and the molecules are able to slide past one another. As we saw on the ice, when like in that last video, it was almost like they were in like perfect lines in the beginning, and they were just still because that way we're frozen. And then as they slowly warmed up, they, we saw what happened. Even though I've said it to you, how would you say that the motion and arrangement of the water molecules changed as the ice melted? Even though I just explained it, it wants me to ask you that.
They change different spots and they are allowed to go all like willy-nilly.
So yeah, I guess they kind of lose their form a little bit. If they get stuck in this way, and then when the temperature starts to change, they start. Yeah. Mhm. All right. So another image. Okay. This is an interesting image. If you need to, I was like, you can get closer. We can probably set these over here because we know what happened. We saw the ice. Oh, the ice cube's not in them. That's why. I'm like, oh, the ice cubes are in there. But I just don't know. I don't know what I'm supposed to do. It tells me to do that, but then I'm confused. All right, so here is a little bit of like a picture of how things look at solid, like how we were looking at that video when they were solid. They were, like I said, almost in perfect lines. And when they become a liquid, they start moving out of that formation and they rub past each other. And eventually, when they become a gas, that's when they really get spread out because, they don't have any kind of form. As I say, as energy is added to the motion of the molecules increase, it begins to overcome the attractions that molecules have for one another. If enough energy is added, the solid melts to a liquid and the liquid evaporates to a gas. As energy is removed, the motion of the molecules decrease and the attractions begin to overcome the motion of molecules. Even if enough energy is removed, the gas condenses to a liquid and liquid freezes to a solid. Okay.
So basically it starts a process from solid to liquid to gas. Then it goes gas to liquid to solid.
Yeah, and they can go either way, but
that cycle.
Exactly, yeah, and you can see, like I see what you're talking in the picture there. Like you said, yep, energy goes away, but that's when energy's added. We know that things go, if you, yep, that's why it's like energy. When energy is added, then a solid will become a liquid, and then a liquid will become a gas, and then if energy is taken away from a gas, it will become a liquid, and same thing, energy taken away from a liquid, it will make it a solid. All right. That didn't work. Okay. Okay, it says tell students that the motion of water molecules in each state of matter is similar to what happens for most substances. This is pretty much just what we were just talking about. I should have looked at it because it's adding Energy increases the motion of the molecules and causes them to move further apart. Removing energy decreases the motion of the molecules and causes them to move closer together. But water does something very unusual when it freezes to become ice. The molecules, which were moving closer and closer together, move further apart as they organize themselves into the open ring patterns shown below for ice. I'm going to look at this to see.
Basically, that's just the paper version of what's on the computer.
I guess I just like when I clicked on the link to get to this worksheet, it was like a whole lot different. There was another lesson it was attached to, and the lesson was a little different. And so I just feel like I'm missing something. But anyway, so it says the molecules which were moving closer and closer together move further apart as they organize themselves into open ring patterns shown below for ice. This is why ice expands when it freezes. So I guess that's what it say. That's why water, when water freezes, it expands, is because the ice gets bigger. I said, and now I was supposed to ask, how are state changes of water similar or different than changes of other substances, like maybe soda or maybe oil for a car? Any specific examples that that you might think are that it could be the similar. You've noticed that it freezes the same as water. Maybe you've noticed it doesn't freeze when it's cold. Anything that you can think of?
Soda, when it does freeze, it's the opposite of water because it takes a different shape sometimes.
Right.
Sometimes it makes that slant, like you're going like it's a sharp hill.
Right.
And then it just ends at a wall.
Okay. Yeah. Like there's things like that.
But then like when you heat it up, it's like just starting to. It's like overflowed more. It's at the top.
Yeah, and that's actually what they were saying right here about water is about that's what makes water special. And that's why soda does that is because there's water in soda. And so the reason it gets like if you were to leave an unopened can of soda in the refrigerator or the freezer, you forget about it, you'll come home and it'll be exploded inside of your freezer because the way it melts, the way it freezes, the way the molecules line up. Sorry, I just got like weird feeling for a second. Okay, so now it says that we're going to complete the remainder of the activity packet, which, like I said, we're going to look at and try to do as a group. It's like looking at our ice cubes, the one in our cup and the one in the water. I'd say this one in this water looks a lot smaller already.
It's moving faster.
Which is what you said you thought would happen. All right, so we don't need to worry about number 3. So instead of writing a caption underneath each picture, it says write a caption underneath each picture to explain how the motion and arrangement of the water molecules change as ice melts. So I think it wants to maybe decide whether you think it's a liquid or a gas. Let me Okay, so I'm kind of confused on what they like. I was looking at what it has for the answer. So it wants you again to write in a caption to explain pretty much what happens with energy. So if we were to look at this one, can you remember what we saw in a video, what was happening when it kind of looked all crazy like that?
When it starts to melt and it goes to a liquid, they could at least rub past each other and get out of their movement. When it starts to turn to gas, it goes all willy-nilly and they spreading apart from each other.
Right, yeah. So this right here, if we had to guess just by looking at this picture, probably say that's a liquid picture.
And repeat the process, but backwards. And they do it forwards again.
What? Oh. See, like I said, I really just don't think that this worksheet goes well with this assignment or this lesson. So it wants us to, so it wants us to go from in water. So what would we be happening if we started here with water being frozen and it was in the process of being turned into a liquid? What do we call that? What is the ice doing if it's getting turned into a liquid?
It's dissolving.
That's close. Is there a better word for that?
I mean, yeah, just melt.
Yeah, melting. Yep, good job. Okay, so what you want to do is you'll put melting, and then so after then when water turns into a gas, what do we call that? Do you know what that's called?
Evaporation.
Yep, exactly. Okay, so perfect. So then, what's that one? This one is a little weird. I don't know, but when you turn from gas to a liquid, it's called condensation. It's because they're gathering up like all the gas molecules and they're condensing them back down into, to get it to that liquid form. Okay, so then you did good with those. It's like I said, I was just figured we could just talk through them rather than you having to sit. Otherwise, I'd just be sitting here quiet and you'd be writing. Okay, so this last form here. So if we were going to turn water, because this is all for water, if we were going to turn it from a liquid to a solid, from water to ice, what is that called? Because we had
condensation.
No, that's condensation is like when the water's what would get on the outside of the glass. You're close. Like you said, melting. So what? It would be the other one instead of melting. It's
condensation.
No, we're close. When we put ice in, you're fine. No, don't be worried. When we put ice in the freezer and we just what are we trying to get it to do? Trying to get it to
freeze.
Yes, exactly. Perfect.
Oh, I thought you mean like that.
No, this just to go from just it's okay. That's why I was like I knew you could get it. I knew that I must have not been explaining it well because it wasn't you. I'm still practicing. I'm not the best at it yet. Okay, so there's that. Let's see what's here. Follow the diagram, use the space filling model to represent the arrangement. All right, so the rest of that's about dry ice, and I did not have dry ice because that was not in, like I said, I'm pretty sure that activity packet goes for the other one. But all right, so instead of that, we just kind of want to make sure that we're wrapping up what we were learning today. Making sure it's still recording. Okay, so so today we talked about states of matter, and luckily you have worked with them before, so you knew a lot of what was going on here, and you were able to make the predictions about, like I said, if we look back right here at our ice, it looks like the ice is completely gone now, so your prediction, and this ice cube is still almost whole, so your prediction was definitely correct. So if we were in a bigger class, we'd have more students who were doing the same thing, and I'm sure you learning like science that after you make an observation, you see an observation, and then
I don't really make group because a lot of people like me.
well, yeah, well, I guess when I am I know you're fifth grade, but in the fourth grade classroom, that I have been in. They just the teacher does it. But when even now if you weren't in a group, like other students in the classroom would be doing the same work. And in science, when you got to test theories, and because everything's a theory, like we could have said that, oh, we're sure that ice will melt in room water temperature faster than just in the air, and that's a like a theory or that's not the right. I'm blanking on the correct words.
A
I know that.
prediction.
Yeah, prediction. I'm like that. So yes, you made the prediction, and then you have to test it, and then, which is what we did. We tested this over here, and we found out that that's correct. And like I said, if we were in a classroom setting, there would have been a lot more other students in here who would have done the same experiment, and they would have realized, they would have all gotten the same results. They would have, so we would all realize. So it's almost, so when after you test something and when you can duplicate the results multiple times, that's when it becomes fact. So I know that did not go as well and as smoothly as I had hoped. I don't know. I'm gonna have to talk to my teacher about it. I have a meeting here in like 20 minutes, so I'm gonna talk to her and ask her, what I should have, if there was anything I could have done better. But for now, I'm just gonna sign off and say have a good night and thank my teacher. Thank you. And if you can wave if you want, you're like, it's okay.